theorem, Euler's theorem, and Wilson's theorem to find remainder. Like Fermat's theorem, we have two cases. Here a raised to power b divided by b, remainder will be always a. Like here a and b are co-prime. You can understand it better with the help of one example. Suppose if I ask you find remainder of 31 raised to power 63 divided by 63. So here power and the number by which I am dividing both are same. So my answer will be 31 directly. You can remember this. Second case is remainder of a raised to power b minus 1 upon b. Here, if you notice carefully, I am dividing by b and the power is 1 less than by the number by which I am dividing. So like this question, find remainder of 32 raised to power 42 divided by 43. So this power is 1 less than 43. So answer will be directly 1. So here a and b are co-prime. This is the only thing which you have to keep in mind in Fermat's theorem. You can remember it very easily with this. Like if this number, power and the number by which I am dividing, answer will be this number. And if the power is 1 less than the number by which I am dividing, answer will be 1. Very easy to remember. Okay. In the same way, we have Wilson's theorem. Wilson's theorem is remainder of factorial a minus 1 divided by a will be a minus 1. Let us see one example. If I ask you factorial 46 divided by 47. See this 46 is one number less than 47. So answer will be directly a minus 1. Mean 47 minus 1, answer will be 46. Okay. See here a is a prime number. You have to keep this thing in mind. And second result is if one number less than factorial a minus 2 divided by a, answer will be also 1. Like if I ask you find remainder of factorial 45 divided by 47. See 45 is just two number less than 47 and 47 is a prime number. So my answer will be 1. So it's very easy to remember. Even if you don't remember the result, you can still keep this thing in mind. If the number by which you are dividing is a prime number and if this number is 1 less than, answer will be that number itself. See here 46. And if it is 2 less than, the answer will be 1. You can remember like this. Now we have one more theorem, that is Euler's theorem. That is remainder of a raised to power function of b divided by b is 1. Here a and b are co-prime number. Co-prime number, you understand the numbers which have SCF as 1. Like 2 and 3 and 4. See 4 is not a prime, but 3 and 4 are co-prime because their SCF is 1. So what I'm going to do in this question, I'm going to express this function as like this: b into 1 minus 1 upon x, 1 minus 1 upon y, 1 minus 1 upon z, where x, y, z, they are just prime factors of b. Like for 10, the prime factors are 1, 2, and 5. For 6, prime factors are 1, 2, and 3. Okay, so it will, if I'm taking the number as 10, it will be 1 minus 1 upon 1, 1 minus 1 upon 2, 1 minus 1 upon 5. If I'm writing function of 6, it will be 1 minus 1 upon 1, 1 minus 1 upon 2, 1 minus 1 upon 3. So x, y, z are nothing but the prime factors of number by which we are dividing. Let us understand it with the help of one example. Suppose you have to find the remainder of 7 raised to power 98 divided 80. See, first of all, here 7 and 80 are co-prime. What I'm going to do, I'm going to express 80 in such a way that I write it in the form of prime factors. So it becomes 16 into 5. What is 16? 2 raised to power 4 into 5. So this is x and this is y. So I can write the function of b like 80 into 1 minus 1 upon 2, 1 minus 1 upon 5. So if you solve it, you are getting 32. So it means I can now take this 7 raised to power 32 divided